Figure 8.14, attempting to modify a constant pointer to constant data. Here we're revisiting basically a very similar example to the one we looked at in the previous video. The difference in this case is that we're going to be applying the const keyword on both sides of the asterisk that's used to declare a pointer. Now in main here we've got two integers, x which is initialized to 5 and then separately the variable y. And our key declaration is at line 14. And again, reading the declaration from right to left, we can say that PTR is a constant pointer to an integer constant. So the pointer is considered to be constant, which means it can only aim at one variable in memory, the one that it's initialized to. And the data it points to is considered to be constant, which means we can only look at that data, we cannot modify that data. So if you're thinking about why you might use something like this, you might pass a large object into a function that needs to look at the data within that object, and you might pass it in as a constant pointer because you want the pointer to always point to that one object for the lifetime of the variable in memory, and then you might pass it in as to indicate that the data is constant so that the function can only look at the data, not modify it. So here we've declared this constant pointer to an integer constant. With such a pointer you can certainly look at what it points to. So we dereference the pointer here to try to output the value. That would output the value 5 if this program compiled. It won't compile, however, because of lines 18 and 19. On line 18 we're attempting to modify the value that PTR points to, but we can't do that because the thing that it points to is considered to be an integer constant. And I can hover over the squiggly to see that the expression must be a modifiable L value. It has to be non-constant is basically what that means in order for me to assign a value to that location in memory. Separately, this line 19 is also generating an error because the pointer itself is constant and therefore cannot be aimed at a different variable in memory. So as we proceed into later lessons, we will typically try to use const in the most robust way we can in a given example to ensure that the data is only modified when it's supposed to be modified, and anytime we encounter a case where the data should be viewed only, read only, we will make sure that we declare that data as constant.